Okay, so the best way to get this going here, we're just going to talk about the types of numbers and define them. I have them all written up here because I'm going to be bouncing around and referring to them all. Maybe not in the order that I have them written on this page, but I think this will just be the easiest way of doing it. The first set of real numbers, like the big set of real numbers that we talk about in Algebra 1, are the set of real numbers. The set of real numbers is any number found on a number line. So that could be anywhere from negative infinity to positive infinity. Out of that set of real numbers, you have two subsets. You have the rational numbers and the irrational numbers. Rational numbers have decimals that terminate. Well, they could have decimals that terminate, or the decimal could repeat a pattern, or it could be written as a fraction. By a fraction, what they mean in this section is a fraction would be a whole number over a whole number. Okay, so that's how you kind of have to keep that in mind when you're going through this. Now, I just talked about whole numbers, so let's jump down to what a whole number is. A whole number is the set of counting numbers, which I have above it, and we'll talk about those, but it starts at 0 and it goes 1, 2, 3, 4, and all the way up to positive infinity. I just mentioned the natural numbers and the counting numbers. Let's talk about that. Now, those are the first numbers that you learned when you watched Sesame Street. If you ever watched Sesame Street, they would do the number of the day, and let's say the number of the day was 4. Okay, so the count would come on, and you'd say, let's count to 4. So you'd start 1, 2, 3, 4. Now, there was no fractions, there was no decimals. You don't start counting with 0. That's why they call them the counting numbers. It's also more commonly known as natural numbers. Most textbooks will refer to these numbers as natural numbers. I kind of use both because I was taught either one. So sorry about that, but you just need to know both of them. Now, the whole numbers is the extension of this, but they include the number 0. Now, an easy way to remember the whole numbers is you have 0 built right into the word whole. So you start with 0 and you go up 1, 2, 3, 4. So it's the set of counting numbers, including zeros. Counting numbers, just like you learned in Sesame Street, 1, 2, 3, 4, no decimals, no fractions. All right, so anyway, getting back to this. So a rational number is a decimal that ends. So like 1.2 would be a terminated decimal, or a decimal that terminates. So the decimal doesn't go on forever. They can go on forever, but if they do, they're going to repeat a pattern. So 0.333333 would be repeating a pattern. 0.1212121212, that is also repeating a pattern. So those numbers would be considered rational numbers. Or it can be written as a fraction. Again, a fraction, excuse me, is a whole number over a whole number. Then you have the set of irrational numbers. It's basically the opposites of rational numbers. So an irrational number is a decimal that never ends, so there is no end to it. There would be no pattern associated with it, so it would just be a bunch of random numbers, seemingly a bunch of random numbers thrown up on the board. And it cannot be written as a fraction. It cannot be written as a whole number over a whole number. So, for example, pi. The number pi is 3.141592, and it just goes on and on forever. People have calculated out to billions of places. There is no repeated pattern. The numbers never repeat. There's no rhyme or reason to it. It just looks like a bunch of numbers being randomly drawn out of a hat and thrown up on the board. That's your set of irrational numbers. Another irrational number would be the square root of 2. So if you had the square root of 2, if you type that into your calculator, like I've done here, the square root of 2, and I hit enter, I get 1.414213562. And now you say, well, the decimal ended because it's not going on forever. Well, the calculator's not going to calculate it out forever. It's trying to tell you, like, look, this keeps going. This is probably far enough as what you're going to need, and that's how it represents it. So the calculator will round it, but in reality, that number would go on and on forever and ever and ever. If you calculated that by hand, you'd be there all day. Well, forever, I should say. Anyway, getting back to this, so we have the rational numbers can be expressed as a fraction. Irrational numbers can't be. Irrational numbers just go on and on forever. The root word being ratio in each of these. So the ratio means a fraction, so it can be written as a fraction or it can't be written as a fraction. It's the easiest way to remember it. So you have the rational numbers and the set of irrational numbers. You have the counting numbers and the whole numbers. Let's talk about integers. Integers, if you wanted to define it without using any numbers as an example like I have here, you would say the integers would be the set of whole numbers and their opposites. So whole numbers, again, go 0, 1, 2, 3, 4 all the way to infinity. If you include the opposites, that would be the negative numbers, it would look like that. So it would be from negative infinity to positive infinity with no decimals or fractions on any of your numbers, and there you have it. Those are your integers. So you could say, are all whole numbers integers? Well, yeah, all the whole numbers are integers, but not all integers are whole numbers, because -3 is not a whole number. Those are a lot of the types of questions they like to throw at you on standardized tests, so you have to know these definitions. And finally, just as a mention, just as a little footnote here, you have the set of imaginary numbers. In Algebra 1, we don't worry about these. Okay, I just want to let you know that it exists, because students sometimes ask me, well, if there's a set of real numbers, is there anything that's not real? Yeah, it would be imaginary. I know it seems a little silly, but in Algebra 2, this is a very, very important number that you're going to use to kind of work your way through some of the math that you're going to encounter. You won't encounter this in our class. It will not show up on your Keystone test, so you don't need to worry about this. I'm just showing you that this number exists, and in case it's on Jeopardy tonight, you know that at least that you're aware of its existence, but you're not responsible for it, so don't worry about it. And those are your sets of numbers, or your types of numbers that we need to worry about.